Good morning, class. Today we are going to start our exploration into proportionate relationships. So I'll spell that for you. That's wrong thing. Make it white. Proportional relationships. Proportional relationships are basically when you have two quantities, which is just two numbers or two amounts that have when like looked at as a ratio, it's multiple pairs of quantities. Let me not say just two. It's multiple pairs of two quantities that when they are set up as a ratio or as a fraction, they simplify or equal the same constant. Okay. We'll explore more and look more into like what I mean when I say that when we get into the lesson. Some of y'all might have remember working with proportionate relationship when it came to unit rate and stuff like that. So we're going over stuff like that. But today specifically, we're going to look at just tables. Okay. I'm going to tell you something in advance, which is that proportionate relationships can be represented in four different ways. Okay. The four different ways are graphs, tables, equations, and written, which is basically a word problem. That's the four different ways that you can see and work with a proportional relationship. And like I said, for today's lesson, we're going to focus on tables. Okay, so go ahead and open your book to page 199, because that's where we'll start, so that everybody get there. Once you know what page 199 is, I'm actually going to, let's start there. So it should look something like this. Okay. So if we read number one says, how are the tables in group A different from the tables in group B? Okay. So we need to go to group A and group B. So group A's tables are on page 205, okay? And group B's tables is on page 207. So real quickly, go to page 205 so we can look at group A's tables, okay? So as I told you before or earlier, a proportionate relationship is shown or displayed when you have a pairs of numbers or quantities that when essentially divided, they equal the same constant, or when they're set up to like a A-B ratio. So it's either A to B ratio, which also can be compared to a Y to X ratio. Okay. So now here's some very important tidbits you need to think about when you're dealing with proportional relationships. You always have an X factor or X item and a Y item. The way you define your X item is that it is independent. So that would be the independent variable. All right. And Y is your dependent variable. The easy way to think about it is whatever in the scenario you're trying to represent with X is something that has control over itself in the situation, where it is what is affecting everything. But more specifically, it's affecting Y. So basically, when X changes, it changes Y, which is how you can think about independent and dependent variables, which means like whatever happens to X affects what happens to Y, which is why X is independent and Y is dependent. Okay. You could actually write this down on a separate sheet of paper, those little notes. It's just a little tad bit. So if we look at the tables, right? We have three different tables, and we're trying to figure out if they show a proportional relationship or not. Okay, so looking at the first table, they have sugar cups to flour. All right, so ideally, we're not necessarily certain on what would or could be the independent and dependent variable here in the sense of because we don't know what we're making, right? So I would say that we could just assume that the first column is X and the second column is Y. Okay, so that would mean when we either, there's two ways you can check this, okay? Either when you divide Y by X, you get the same number each time, or you can check and see if they are increasing by the same, not by the same amount each time, but like increasing at the same rate. And I'll explain what I mean when I say that. So if I look at sugar, right? Sugar's at 1/4. To get from 1/4 to 1/2, you would be adding 1/4. Okay, to get from 1/2 to 3/4, you would be adding 1/4 again. And to get from 3/4 to 1, you would also be adding 1/4. So if on the other side, you are adding an amount, just like you're adding a certain amount on that side, as long as they're increasing by the same number at the same time, there would be a proportionate relationship. So if we look at this one, it says that, okay, it's 3/4. So to get from 3/4 to 1 1/2, that would be adding 3/4. Okay, to get from 1 1/2 to 1 1/4, that would be adding 3/4. And to get from 2 1/4 to 3, you would add 3/4. So in this situation, these things would be proportional because when sugar is adding 1/4, flour is adding 3/4. So like they're increasing by a constant number at the same time. Okay. Also, if we were to divide this number by this number, we should get the same number each time, every time we divide Y by X. But I'll show that with a different table. Okay, so we know that this table is proportional. If we look at the next table, this table over here, one way to initially tell that it has a most likely it's proportional is because that it has the coordinate 0 0. So as I said before, right, you have an X and you have a Y. So if I look at, let's say, the volume of sample V's cubic centimeters, the mass of sample M in grams. Okay, so essentially, I would believe that, like I said in the first one, that this is X and this is Y. Now, volume does have a specific formula, which is, I think it's mass times density. Or no, trying to get into science. I'm not sure right now, but if we assume that this is X and this is Y, right, we would just have to find a certain particular things, right? So the first thing is that since it has a 0 0 coordinates or a 0 0 starting point for X and Y, that is a hint that most likely you are dealing with a proportionate relationship. Also, when you have a proportionate relationship, a way to shortcut and find the constant or the rate that the item is increasing by 1 would be whenever X is 1, this is your constant, which I'll get more into that as the lesson progresses. So ideally, every 1, the item on this side should increase by 2.5 2.7. So since it skipped to 5, ideally 5 times 2.7 should equal this number. So, you can put it in your calculator. I'll put it in my calculator real quick. So 5 times 2.7 does equal 13.5, so that would be correct. And then also 10 times 2.7 should equal 27, which it does. So this table also has a proportionate relationship where the unit rate, okay, because I know y'all are used to hearing it like that, but it also is called the okay, hold on, go back. The constant of proportionality. Okay, so constant proportionality slash unit rate is for this table 2.7. So this one is showing a proportionate relationship. And then finally, for the last one, if we look at it, it says the height of a prism in inches to the volume of it in cubic inches. Well, we know that the formula for volume is length times width times height. So most likely this is X because this is needed in order to get Y. So that would mean if we divide Y by X, we should get the same number. 12 divided by 1 is 12. 48 divided by 4 is 12. 96 divided by 8 is 12. And 120 divided by 10 is 12. So that means the constant in this table is 12. Okay, meaning also that if I took this number and multiplied it by each of the X numbers, I should get the Y values that correspond with it. So this table is also showing a proportionate relationship. Okay. So if we sum up what we've just looked at, a proportionate relationship can be found out in a difference of ways. So if you see that as one value is increasing by a set amount, another value is increasing by its set amount, that is a proportionate relationship. If you can, okay, I'm down here now. If you can divide the Y value by the X value and consistently get the same number, that is a proportionate relationship. And then this table, which kind of gives us a little shortcuts, if your table has a 0, 0 value, that is a hint that it is showing a proportionate relationship. But just in case you would want to check, and remember I told you when X is 1, you already have your constant of proportionality or your unit rate. So then you can use this times your X values to see if you get your Y values. Of course, this is a lot of talking, and I haven't actually worked anything out yet. So this is Pedro's group A. Now let's go to page 207 with Pedro's group. Okay, so now looking at Pedro's group B, we would ideally do the same thing we did for Pedro's group A. We would try to check and see if we can find a constant or if the numbers are on both sides are increasing like at the same time in a constant fashion, something of that nature, right? Or if we go to where X is 1, is that the constant that's being used, so on and so forth, okay? So we look at the first, we look at the first table over here. We see that we have time in hours versus cost in dollars. So we actually do have a 1. So technically, the way that proportionate relationships work, this should be the constant, which means that I should be able to multiply that number times the rest of my X numbers to get the opposite result or the Y or the outcome. Obviously, 22 times 2 is not 29. 2.5 times 22, I don't believe it's 3250. I'm pretty sure it's not 25 times 22. Yeah, that's 55. And 4 times 22 is definitely not 43. So this one is not showing a proportionate relationship based on the information that they're giving us. Looking at the next one, this would be X and this would be Y because you need length in order to get area. So that would make length independent. Area depends on what the length is, right? See how that independent-dependent relationship works. So we can look at it in a couple of different ways. So you could say that this side is decreasing by 1/4 each time. Well, actually, no. It decreased by 1/4 in the beginning, but then it increased. Oh, no. We could say it decreases by 1/4. It's very weird. Well, no. Not decreases by 1/4. Increases by 1/4. Find a common denominator. That would be... No. It increases by 2. Like multiplying by 2. Yeah. If you multiply this by 2, you should get the next number. If you multiply this by 2, you should get the next number. And if you multiply this by 2, you should get the next number. Okay, so very good. These are all being multiplied by 2. So we can kind of try to see if there's a proportional relationship on the other side. So on the other side, I would say it's working not the same way. You're multiplying by, I want to say 4. 4 divided by, yeah, so you could multiply by 4 here, multiply by 4 here, and multiply by 4 here to get the next number. But the problem once again would come in at that this is a 1, right? So that means the number opposite of when x is 1 should be the rate that it's increasing, which means that I should be able to multiply this number times these numbers to get their counterpart, and that wouldn't work. So even though it is increasing by the same rate, it kind of cancels itself out. So this one doesn't work either. And then so the last one where we have days and a number of bacteria that grows over a certain amount of days. So once again, if we go to where x is 1, this number should ideally be able to be used to multiply times the other x's, and including this one, to get their opposite answers. So 2 times 0 would be 0. So this should be 0, but it's 1. So that's the first mistake. 2 times 2 is 4. So that one works, and 2 times 1 is 2. So 2 in the middle work with 2 as the constant, but then once again, 3 times 2 is 6. So this one wouldn't work. So all of them don't work here. Even if I wanted to check it the other way, where you divide y by x, 1 divided by 0 is 0, 2 divided by 1 is 2. So we're already not, so this one doesn't work either. So Pedro's group B all shows non-proportional things, okay? So now if we go back to page 199, if I'm not mistaken, yep. The first question that says, how are the tables in group A different from the tables in group B? It's a very simple answer of that the tables in group A are showing a proportional relationship. while the tables in group B are not. Okay. So a very simple answer there. Then number 2 says describe a proportional relationship in your own words. So, you can go ahead and make an attempt to describe proportional relationships in your own words. Pause the video. Think about the things that are said. Okay, so your answer should have been something along the lines of when you have a pair of quantities, which just means a pair of numbers that make equivalent ratios, / when you divide them, you get the same constant, or you get a constant, the same answer, would be something around what you wanted to write. Because an equivalent ratio and dividing to get the same answer is the same thing. Okay, because we know that ratio and fractions are closely related. They're not the same, but they are closely related. Okay, so now we can turn the page to page 200. Okay, where we have some more tables to look at. All right, so number 3 says consider the following tables. All right, so we need to look at all of the tables. But let's read part A to see if there's any goal that we have when reading the tables. Part A says determine whether each relationship is proportional. Explain your reasoning. Okay, so remember we're boxing our verbs. So determine would be the verb. What are we determining? Whether each relationship is proportional. We actually have a second set of instructions. Explain. What are you explaining? Your reasoning. Okay. So we have 2 things to do in order to answer this question. And we need to answer in complete sentences. All right. So now we need to analyze each table. So I'll do table 1 with you, and then I kind of want you guys to kind of look at table 2, 3, and 4 on your own and see what you kind of figure out. So if we look at table 1, I could look at this in multiple ways, right? So if I use my hint or my technique, well, first of all, I have to classify out of the 2 things, what is the X and what is the Y. So it says number of days, number of hours. In the situation of days to hours, the amount of days that you're using would be the control variable or the independent variable, and hours would depend on how much of a day or the amount of a day you're talking about. So half a day being 12 hours, we know that it's factually correct. But, let's use some of our techniques to check it. So from a half a day to a whole day, that would be plus a half. Okay, from a whole day to a 1.5 days, another plus half. From a half a day to a third day, they actually skipped a couple numbers, right? So we can see that there was a pattern at first, but we can't use this method to check it since they skipped numbers. So now we have to try something else. Okay, so now we can try the method where we divide y by x. Okay, so we divide y by x, 12 divided by 1/2. You have to turn 12 into a fraction, so that's 12 over 1. Then you're dividing fractions, so you keep, change, flip. So that would turn into 12 times 2, which is 24 over 1, which means this would equal 24, okay? Then we know that 24 divided by 1 should equal 24. If you do 36 divided by 1.5, you should also get 24. And then if you do 72 divided by 3, you should get 24. So this table has the same constant or an equivalent ratio when you do y to, or a to b, or y to x, or divide y by x, or divide a by b. So that would mean this is showing a proportional relationship. And once again, just to explain it to you, the way you would properly use this number that you find, if you multiply this number times your x value, it should equal what your y value is, which it does. So table 1 shows a proportionate relationship because it has a constant, or shows equivalent ratio between the pairs of quantities. Okay, so you can go ahead and pause the video to attempt to see if 2, 3, and 4 have equivalent ratios, or like proportionate relationship. Try to do what you've seen me do. You can approach it in multiple ways. So go ahead, pause it, and get to work. All right, so if we look at table 2, if we try to do the method of seeing if they're increasing by their own like number, consistent number, but like matching on each side, I mean from 36 to 40 is a -4, and then from 40 to 50 it's going up, so that wouldn't show consistency there. It's kind of the same thing on the other side. You go from 12 to 15, which is +3, but then you go from 15 to 16, which would be +1. So that wouldn't really work. And I mean, if we try to divide them, let's see, you got number of bats versus number of hits. So this would be your X, because the number of bats will control how many hits you actually get the chance of getting and actually getting. So you divide 12 by 36, that would be 1/3. Then if you divide 15 by 40, you would get like 0.375, which is, I want to say, 3/8. So those are not equivalent ratios. They're not, and the constant is not the same. So this one doesn't show a proportionate relationship. If we look at table 3, you have the area, square feet, and the total cost of the tile. So the area would be the independent here, and depending on how big the area is, that would be your cost. Please pay attention to how I'm defining X and Y, because you will have to define X and Y yourself. So that means we could do the same thing, right? We can see if they increase by the same number. So if we do X, this would be +30, +30, and +30. So X has a little pattern at the top, but does Y do its own pattern while X is doing its pattern? So let's see. To get from 1,800 to 2,160, you would have to add 360 to get there, and then to get from 2,160 to 2,500 or 2,500, you would have to add 340, which is not the same number, so it is not consistent. It doesn't have a consistent rate, so that one would be out of the question. And if you wanted to know what we had to add to get from this to this, it would be 380. So since it doesn't show consistency, I will go ahead and say that this one is not proportional either. I'm pretty sure if we divided Y by X, we wouldn't be getting the same number. So that would be another reason why it's not a proportionate relationship. So then if we look at the last one, we have lemonade L cups, compared to lemon juice. Okay, so if we do the same thing where this is X and this is Y, so lemonade would be X because you need to know how much lemonade you want to make and that determines how much lemon juice you use. Like, you need to know how much you want to serve. Okay, so if I know I want 1 1/3 cups, that means I need 1/3 cup of lemon juice. Okay, so in this situation, it probably would be a lot easier to just go ahead and divide Y by X, because trying to find a consistent number between the values looks like it's going to be very kind of tricky. So dividing Y by X, that would be 1/3 divided by, I have to turn 1 1/3 into an improper fraction. So that'd be 1 times 3, which is 3, plus 1, which is 4. So that'd be 4 over 3. If I go across, that'd be 4. Oh no. When you divide a fraction, you have to do keep, change, flip. So that'd be 1/3 times 3 over 4, which would equal 3 over 12, which can reduce into 1/4. Okay, so I got 1/4. If I wanted to test this out to see if this was the constant without having to divide again, which I probably am going to use since we would be dividing fractions, right? I would do 1/4 times 2 and see if I get a half. So if you want to put that in your calculator, that would be 0.25, right? Because 1/4 as a decimal is 0.25 times 2. You get a half. So it's working. I'll skip this fraction because I don't want to deal with it and see if it works for this one. If it works for at least 2 of them, you can kind of assume that it's correct. I don't want you to get in that habit. So we check 2, but to make sure we're right, we check at least 3 because you will have problems that could fool you. So if we do 1/4 times 4, that should give us 1. So I'm pretty sure this one has a proportionate relationship where the relationship between them is 1/4, or the constant, the equivalentness is 1/4. Okay, so now to answer part A, because I still never answered it, now that I've looked at each table, it says determine whether each relationship is proportional or not. We would say that table 1 and 4 have a proportional relationship, right? And you would say because the quantities, the pairs of quantities are equivalent / equal the same constant or same number. Then that'll be your first sentence. And then your second sentence will say that tables 2 and 3 are not proportional because the pairs of quantities are not equivalent / don't come out to the same number or constant of proportionality. Okay, so that would be what you have to write to correctly answer that question. So let's move on because we'll have time to work on that to part B. Part B says use table 1 to write an equation relating the number of hours to the number of days. Okay, so if we're looking at table 1, right, when they say relating the number of hours to the number of days, okay, since hours is X, because that's what I called it, but are equal to H, and days, or D, is equal to Y, we had to do something to X to get Y. What did you see me do, or what did I say we could do? Because that's how we will write our equation. So if we go back and look at it, I said that we could multiply that constant number we got, right, which was 24, times X in order to get Y. Okay, so that means the equation that we could write to represent the relationship between the two numbers would be that D, which is days, but I put Y above it, equals 24. It looks like a 9. 24 H, or 24 times H. Okay. And then they ask you to do the same thing for the lemon juice and the lemons in part C. So I actually want you to pause it to see if y'all could put that equation together based off of what you just seen me do. Okay. All right. So what you should have came up with is, remembered, I told you there was 1/4 between each one. And we know that X is the lemonade, or L. So that would mean that 1/4 L, or times L, should equal J, or the amount of juice you use. Okay, very simple, you know. So now, before we move on, I'm gonna quickly talk about a topic or something dealing with proportional relationships that I can give you ahead of time now. So there is a set base form equation for proportional relationships. Okay, that equation is y equals kx. Okay, so when you look at the equation y equals kx, like I said, that's the base form of the equation. What you need to remember about y, k, and x is what they represent more than like what the actual letters are. Like, you need to know the format of the equation. Like, you need to know it's always y equals kx, but what you need to know and remember is that y is always your dependent variable. Okay, so that means whatever variable they put here, or variable you think fits the description of y, just in case it's a different letter. Because as you can see in B and C, I didn't put y, I put D and I put J, because that's what those tables were talking about. That's what variable they used. But D and J still represent the same thing that y represents. Okay, so, and that x is your independent variable, right? Which, once again, if I use the examples from B and C, H would represent the same thing that X does, and C would represent, I'm not C, L will represent the same thing that X does. They're independent, they can stand on their own. And then K is usually the result, or the number that you get when you divide Y by X. So if you're ever trying to figure out what K is, K equals Y divided by X. Okay, that is very important. You should definitely write this down if you didn't write it down the first time, because I will be referring to this. We will be using this for a while, so you need to know it. You should get it stuck in your head, because it's going to get very repetitive. Okay. And I'll go into more detail when I get back to school on Tuesday, like why the things are the things. But let's keep going. If we look at number 4 says consider table 1. All right. So consider, it's just telling us to look at it. So if we look at the table, this is the same table from problem 3. So we've already really broke this down. We know that the constant, or the equation that we can use for this table, would be D equals 24H. Okay, so now what's important to understand about this equation is that if we look at the table, right, the table only shows us for a half a day, a full day, a day and a half, and 3 days. Using this equation gives you the option to say however many hours you want, right? So you can fill in H with any number, and you should know how many days you'll get from that many hours. Or you can put in how many days you want, and you can get how many hours you'll get from that. Okay? So I actually think I have the variables in the wrong spot. I put H on that side. It's supposed to be DH, because this was Y and this was X. Yeah. So still the same concept, but make sure your variables are in the right spot, because as I told y'all before, Mr. G makes mistakes. Oh, I can't. I'm going to scratch it out. Scratch it out. This is supposed to be H, and this is supposed to be D. Okay, so anywho, if we proceed to go through the problem, okay, it says, part A says, how many hours are in 4 days? So if we look at the table, there is no 4. but we know that days is represented by D. So if we plug in 4 into our equation, so that'd be 24 times 4, it should equal how many hours that is. So in your calculators or in your head was 24 times 4. You should get 96 hours. Okay. And then part B says how many days are in 300 hours. So same process. We don't have it in our table, but we have the variable H, which means instead of H, we can write 300 equals 24D, right? And then we do our solving equation technique, which means we can divide by 24 to get D by itself to figure out what D is. So D would equal 300 divided by 24, which is, so that would be 12.5 or 12 and a half days. Please make sure you write what these numbers represent when you're writing your answer down, because that is very important. If you just write a number and I don't know what it represents, that will be wrong. Just letting you know. Okay, so you should get the gist of what we're doing so far. So let's move on to the next problem, where now they just want us to consider the other table, which is table 4. So once again, we know that the equation for this table was this was X and this was Y. So that means that J equals 1/4 L, right? So it says how many cups of lemon juice are needed to make 15 cups of lemonade. All right. So I want y'all to pause the video and try to do this one on your own. And if you think you got A right, try to do B on your own too. Because you're doing the exact same thing I did in number 4, where I just plugged in a number and solved for that number. Okay, so go ahead, pause the video. All right, so since we already had our equation, which allows us to play with different numbers, it says how many for 15 cups of lemonade. So I know lemonade or cups of lemonade is represented by L, so that would be 1/4 times what? Times 15, which should give me how much lemon juice I need for 15 cups. So I know 1/4 is 0.25 times 15, which equals I would need 3.75 or 3 3/4 cups of lemon juice. So once again, you see me writing what the numbers are. Do not just write the numbers. I will mark it wrong. Okay, so if you didn't try part B, I want you to go ahead and try it now. Part B says how much lemonade can be made with 1 2/3 cups of lemon juice. So the process is still the same. You're just subbing in a different variable and solving for a different one. Okay, so go ahead, pause it. All right, so now we have lemon juice versus lemonade cups. So that would be 1 2/3 is equal to 1/4. It's constant, it's always in the equation. L, we are solving for L. So remember, I told you guys, in order to get a fraction with just its numerator, which would work because we will want 1L, because then that means L is by itself. You multiply it times its denominator. So if I multiply this times 4, it'll cancel this 4 out, leaving me with L equals this times 4. So now to multiply this times 4, I will put 4 over 1, change the mixed number to improper fraction. 1 times 3 is 3 plus 2 is 5 over 3 times each other. That would equal 20 over 3. I could make this a mixed number since we were using mixed numbers. 20 divided by 3, you can get 6 threes out of 20, and then it would be repeating, so that would be 6 2/3 cups of lemonade can be made with 1 2/3 cups of lemon juice. All right. And even though I haven't talked about it, I will say that if you wanted to know if your equation was correct, like if your problem was right, all you would have to do is plug it into the base equation for that table or for that proportionate relationship for both answers, right? So if I do it for the first one, right, that would be that 3 3/4 is equal to 1/4 times 15, which that's how we got 3 3/4. So we know it would give us 3 3/4 is equal to 3 3/4, which means that that answer was correct. And you would do the same thing down here for part B, where you would say that 6 2/3 is equal to no, hold on, go back. That's actually the wrong side. You would say that 1 2/3 is equal to 1/4 times 6 2/3. So you would have to do that math to figure out that most likely 1 2/3 is equal to 1 2/3, which would mean this answer was correct. Okay, so there is, just like with regular solving equations, a way to check your work with this, and we will work with checking our work with this because we need to know we have the right answer and not think we have the right answer. Okay, so we move on to the next page. The next page says Nora summer job. It has 4 parts, so I'll read through it for you. It says Nora has a part-time summer job. The table shows the proportionate relationship between the amount of money Nora earns and the number of hours she works. Okay, so if we're just looking at the table before we even look at what they're asking us, we have to determine what is X and what is Y, what is independent, what is dependent. So in this scenario, she has a job, right? So most likely her hours or the time would be X, because if she does not work, she does not get paid. So that means her money she gets paid is dependent upon how many hours she works, which is how I define it as X and Y. Okay. Then we would say, we read A, it says, when the rate for Nora's earning is expressed as the number of dollars earned per number of hours worked, what is the unit rate? Explain what the unit rate represents. So what they want us to do, okay, is to find basically how much she gets paid per hour. All right, because when you're finding proportionate relationship or finding a unit rate or the constant of proportionality, remember what I was saying when we were looking at the tables before. If you can figure out when X is 1, then that means the number that is across or in the same column as when X is 1 is your unit rate. That is your constant of proportionality. That's the number you would use to figure out, like, to make your equation, which would give you access to figure out a plethora of numbers and ideas. Okay, so they don't have that for us, right? So in order to figure out, we would have to divide Y by X. Okay, so if we divide Y by X, we would have to make them the same thing. So either I would have to change my fractions to decimals, or I would have to change my decimals to fractions. So, I mean, you could do either one. So I'll break down how to do either one. If you're changing the decimals to fractions, this would be 2.5. 5 would still be regular. This would be 0.5. And then this one would be 4.2. Okay. But if you're changing the decimals into fractions, this would be 28.2. 3, not point, why did I say point? 28 and 3/4. This one would be 57.5. This one would be 5 and 3/4. And then the bottom one would be 48 and 3/10. Okay, so you can use either one. I probably would use decimals if I was you, if I was me, just because it's a lot simpler. So if I divide 28.75 by 2.5, I get 11.5. All right, so $11.50. Ideally, since we're talking about money, but let me make sure that I get that answer again at least 2 more times. So I'm gonna also do 57.5 divided by 5, which gives me 11.5 again. And then, like I said, we do it one more time. So then we would do 5.75 divided by 0.5, which gives us 11.5. So that means 11.5 would be our unit rate, or our constant of proportionality. So to answer the question, it says, what is the unit rate? The unit rate is 11.5. And then it says, explain what the unit rate represents. The 11.5 would be that the amount of money that Nora gets, why I put gets like that, gets paid per hour worked. Or you could just say per hour, because that's how we talk about it in real life. Okay, so that's basically her pay rate. She gets paid $11.50 per hour. Okay, $11.50. So now part B says, write an equation relating the amount Nora earns D in dollars to the number of hours she works. Okay, so I actually want y'all to try to figure that out, because we worked with that a little bit earlier in number 4 and 5. So pause the video and see if you can make an equation with your unit rate and your constant of proportionality relating her hours to her earning. Okay, so if you remember what I said about this number, the unit rate, you should be able to take this number and multiply it to your X numbers to equal your Y number. But in this situation, that would mean you would be multiplying 11.5 or 11.5, depending on how you want to represent it, to H, because that's what X is. X is H, or hours, right? To equal D, which is how much she gets paid. Okay, so either one of these will work because they're representing the same thing. All right, so now if we look at part C and D, part C says use the equation from part B to determine how much Nora earns for working 3.5 hours. And then D says use the equation from part B once again to determine the number of hours Nora works to earn $51.75. So I want you guys to figure these two problem parts out on your own. I will check them when I come back to school. After you finish that, you can start on the homework.